All right, we are on the ACT problems 82 through, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So through 81. All right. So, which of the following inequalities must be true? So we already know how to solve this. So if P needs to be greater than 2, we're going to go ahead and let P be 2 because we know it's going to have to be greater than 2 anyways. So P has to be greater than 2. So I'm going to go ahead and multiply both sides by 2. So that'd be 4 plus Q greater than 10. Minus 4, Q would have to be greater than 6. Next one. This one is fairly easy. Now notice, when we're dealing with something like this, we have 1x squared minus 4x squared plus 1x squared. So if I combine all my like terms on top, 1 minus 4 is negative 3. Negative 3 plus 1 is negative 2. So we got negative 2x over x. Whenever we're dealing with exponents, we subtract. 2 minus 1 would give me x. For what values of m and n would the following system of equations have infinite solutions? So what needs to happen is these need to be the exact same equation for them to be infinite solutions. So let's see. So if this is negative 6, then this would really need to be a positive 6. So I'm going to go ahead and multiply this by 3, by 3, by 3. So this would be negative 9x plus 3y equals 6, because everything would need to cancel. These would cancel. So the next thing I would need would be negative 3y. So I know my n has to be negative 3. So I know my n has to be negative 3. And I know that my x has to be positive 9. That would make everything cancel. So when it says infinite solutions, it means when everything cancels. So I know it has to be D. What is the smallest integer for which the inequality is true? So the first thing is I need to go ahead and solve this. I'm going to multiply everything by 4 like I've taught. So this would be x minus 1 greater than or equal to 4. So I'm going to go ahead and I'm going to add 1 to both sides. X needs to be greater than or equal to 5. So 5 would be the smallest number in which would work. Number 86, which of the following equations will always have the same solution? So let me think about this. So we have to have the same multiple. So they got rid of their denominators. So they're going to multiply everything by 2 and 3. 2 and 3, 2 and 3, 2 and 3, 2 and 3. Just like I've taught you. So the 2's go away, the 3 go away. 2 times 3 is 6. 6 times 4 is 24xy minus 6 equals 3x plus 2y. These are identical. Which of the following inequalities represents the set of values? We already know that we're going to get rid of 4. So negative 3x greater than 2. Divide by negative 3. X needs to be less than or equal to negative 2/3. Because we flip our sign, so we know it's A. What value of A is a solution to the inequality, but is not a solution to the inequality A minus X greater than C? So, equal, so the only difference is equals, so let's see. If I'm trying to get a by itself, I'm going to add x to both sides. So I know that c plus x is a solution. So a could equal c plus x on this one, but it cannot equal on this one. That's the only difference. If 3 to the xy equals 1/9, 2x plus y equals 0, and x is positive, then x plus y. So the first thing I need to do is I need to go ahead and solve. But how am I going to go ahead and solve this? So the first thing is I know that 1/9, this is actually algebra 2, this would be 1/3 squared. And I know that 3 squared, 1/3 squared is the same as 3 to the negative 2. So that means that if I have 3 to the negative 2 and I have 3xy, when we have the same base, we know that negative 2 has to equal x times y. And I also know that 2x plus y needs to equal 0. So what we can do is we can actually substitute. So I know that y has to equal, if I get 2x by itself, y has to equal negative 2x. So I'm going to go ahead and plug in negative 2x. So that would give me negative 2 equals negative 2 x squared. Divide by negative 2, divide by negative 2, 1 equals x squared. So I know that x has to equal 1. So if x equals 1, then y has to equal negative 2. So 2 times 1, negative 2 times 1 would be, where did we mess up? Oh, x equals 1. Where did I mess up? Let me go ahead and look at this more, and we will visit this in class so I can look at it more clearly. Oh, x plus y. So 1 minus 2 is negative 1. There we go. I was wondering what was going on. So this was really a systems of equations, and the first thing is we had to get the same base because that's what exponents are. This is what you're going to learn in Algebra 2. So this is Algebra 2. If k equals negative 1, then, so x plus y over negative 1 squared. So then what do we know? So this equals, so I know that so I know just in Algebra 1 that this would be x plus y squared over 1 squared. So x plus y times x plus y. So that would give me x squared plus xy plus xy equals y squared. So this would give me 2xy, so I have x squared plus 2xy plus y squared. So that would have to be C. Last question. Logs. So logs is whenever we take 2, that's our base. 3 becomes our exponent, needs to become x. 2 to the third would be 8. This is Algebra 2. And we are done.